4 assignments left.
Okay.
Okay, so let's get this going. All right, so determine the intervals of the function. Okay, this one might I might need you to look at this one.
Okay. Oh, all right. Make you the presenter.
Alrighty. And it is toasty today. I might have to go turn the air.
It is get hot today. Really hot.
Yeah, it's super hot. It got hot quick too, because this morning it wasn't that bad.
Yeah, no, I know. All right. Here we're talking about increasing, decreasing, and constant.
Okay.
Start from the left.
So that looks like it's increasing if I'm starting from the left.
Until which point?
-4, -3.
No. -6 is the x-coordinate where it stops increasing.
Oh, okay, never mind. I know what you're saying now.
Right, correct.
Yeah, I figured it out now. I thought you meant like when it hit the end of when it...
What is the interval on which that's increasing?
Like where it starts to increase, or?
Always start from -infinity. If there's this arrow, that means it goes on forever. Right? That means it goes on forever, right?
So it would just be -infinity 2. Wait, no. Be -infinity, yeah, parentheses. -infinity,
comma, what's the x-coordinate? Remember that you're talking the x-coordinates to define these things, not the y, the x-coordinate.
Not the y. So you'd get -infinity, -3.
What's the x-coordinate?
That's a y. -7. Where it's pointed at? Where it like touches the line, or where it's pointed at?
Point your cursor at where it stops increasing.
Oh, where it stops increasing right here.
That's the x-coordinate.
Okay, so it's -infinity. What? No, that's
comma. Now, you're not looking at the y-coordinate. Do not look at the y-coordinate. You're only looking at the x-coordinates. When they talk about functions increasing, decreasing, and constant, they want you to give the answer in terms of the x-coordinate.
So we get -8, -6 then?
Negative
or -infinity, comma -6.
Go ahead and let me watch how you put that in. That's just the first one. There's another interval where it's also increasing. Let's get the first one in there.
Okay. This is it though, right?
That's the first place that it's increasing. Okay. Now, in union with. So you need to get your cursor to the right of that right parentheses. Over here in your answer. Yeah, to the right of the right parentheses. And now use the, I don't see it on your thing, in combination with. In other words, interval notation uses the U. Do you have a U anywhere?
Oh, yeah.
Yeah, click on more. Yeah, you want that U right there, okay? That means there's more than one interval.
Okay.
The first interval was -infinity to -6. Where's the next place that it starts increasing?
Right here.
What's the x-coordinate of that?
The -1.
Okay, that's the first thing you want to put in there. Comma. Where does it stop increasing?
0, if you're looking at the x.
Always.
Okay.
Well, I shouldn't say always, but when you're talking about increasing and decreasing and constant, yes. That should be your answer. I don't see anywhere else on that function where it's increasing.
Okay, cool. So
that works.
Awesome.
Okay. Now, where's it decreasing?
Right here. Yeah, just right there.
Decreasing.
Where does it start decreasing? -6.
Okay, that's parentheses -6.
Parentheses -6.
Decreasing.
-4.
Okay. End parentheses. Now, is there anywhere else where it's decreasing?
No. Going from the left to the right, there's no other place to decrease this.
That's the final answer. In other words, you don't have two intervals. The first one had two intervals, and that's why you used the U.
Okay.
Okay. Now, where is it constant? And this also has two intervals. You're going to have to use the
right
U. Okay, go ahead.
Right
Answer it total.
Okay. So we get -4. Oops, that's not a comma. -4, -1. I'm going to put a space. I feel like the space.
Don't know if it needs it or not. It might. Yeah. Might not. It probably accepts either. But these Math Excel, boy, they can be picky. That's not where the next. Yes, it is. Sorry.
Okay.
Answering a different question here.
Is that it?
Perfect.
Awesome. Okay.
All right.
Okay, I don't know what these mean.
I'll leave you being the presenter as long as we're answering questions on graphs.
Yeah, graphs are kind of easy to do. So it says identify any relative maxima or minima and intervals on which the function is decreasing and increasing. I don't know what a maxima or a minima is. Clearly it means bigger and smaller or up and down, but like.
Right. Merrick, what's your subject course you're taking? Are you taking Algebra 3 or pre-calc or what?
This is college algebra.
College algebra. Okay, that's like Algebra 3. What they're really directing you here towards is calculus.
Okay.
Okay. In other words, when you get to calculus, figuring out where a function's maximum and minimum are within a certain interval is very important.
Okay.
One of the huge things. So if you look at that curve, you'll notice that there are, first of all, let's distinguish between maximum, absolute maximum, and relative maximum.
Okay.
That point at -3, -1, that's a relative maximum.
Well, yeah, because technically this would be the maximum, right?
Well, technically infinity. There is no maximum.
Yeah. So this is the relative maximum of the function.
If somebody said, what's the absolute maximum? The answer is undefined.
Okay.
But if somebody says you have a relative maximum and you have a relative minimum, it's those 2 points.
Okay.
So identify any relative maximum. Okay, so go ahead and put -3, -1. That's a relative maximum.
Okay.
Well, hold on just a second. Now this is where it gets confusing. The relative maximum is the y-coordinate. It occurs at x equal -3. So go back to relative maximum and change that. The relative maximum is the function value, the y value. And what it is -1.
-1. Why is it -1? Is that because it's a...
because they made a mistake in graphing it.
Oh, okay.
You'll notice that should be -3, 0.
Yeah.
Right?
Because if it was 3, 1, it would be like...
well, it's just not graphed correctly. That y-coordinate is 0, but they've labeled it -1. So let's answer -1, and where does it occur at x equals?
-3.
Okay. In other words, you kind of have to get used to whether they're asking for their answer as the y-coordinate or the x-coordinate.
Okay, so this is the x-coordinate, obviously.
The x-coordinate, a lot of them are what is the maximum? That would mean the y value. So go ahead and put in -3, and let's see if it takes it. Because their graph doesn't show that.
Yeah, it worked. Yeah, so the relative minimum.
Right. If they label the points regardless, notice that the point they label on the next point is also not even close. Oh, I see what's happening. They've made their grid such that each grid mark is 10 units. So -1 actually was really, really close to the x-axis. It's only 1/10 of that grid down, so it doesn't really show as being at -1. It showed it being at 0. So the minimum is where?
The minimum is right here. So
Tell me the answer to these two questions.
would it be 1 negative, or would it be negative 9, 1?
Perfect.
Cool. All right, it's not continuing. Oh. On which intervals is the function increasing?
Multiple choice.
So this is increasing. Yeah, that'll work. Thanks. Yeah.
So
okay.
Notice that first interval for A.
Yeah.
Is that correct?
Well, because it's not negative infinity though, isn't it? Because
yes,
if it's increasing.
When you start from the left, you're starting at negative infinity.
Oh yeah, that's true. Okay.
So hold on. That doesn't mean it's the right answer. We got two answers that have that first interval. But it allows you to narrow it. You know, it's either A or D, right?
I think
both
it would be
A
D,
and
though.
D have that same first interval. And that's the correct first interval. Negative infinity to -3. But there's two answers on there. What's D say? Which one has the correct second interval?
I think it would be D because...
Because it increases all the way to infinity.
Yeah, okay. Cool. Continues. There's still more to this?
Oh, yeah.
Which interval is a function decreasing?
It's definitely calculus. See, in calculus, it makes a huge difference whether functions are increasing, decreasing, concave down, concave up, all of those things.
Would it be this one right here?
Yeah, let's see. It's from remember, we're defining this in terms of x, so it's -3 to 1. It looks like A. Oh, no, it looks like D. -3 to +1.
Oh, okay. All right, yeah.
But you got to be careful. These problems are easy. They really are. You just have to pay very much attention to detail.
To graph the function, estimate the intervals on which the function is increasing or decreasing at any relative maxima or minima.
Okay.
So we have f of x equals 10 minus, that's like, I don't remember how to verbalize that. This right here.
That's absolute value of x. Let me be
the
presenter for a moment. I'm going to switch over. Can you see my screen?
Yep.
So we have to figure out how to graph that. What we have to do is recognize
that makes it positive, right?
Well, what's the parent function? You have to figure out what we have is a transformation of a parent function. That's always the best way to graph these oddball functions. Okay? What's the parent function?
Y equals 10. Okay.
Always think in
y
terms
equals
of the variable.
B.
That's the parent function.
Okay.
Okay, how do you graph that?
Well, first you have to make the absolute value just positive, right?
Well, it's a V.
Okay.
Always know that absolute value functions graph as a V, either pointing upwards or pointing downwards. They can have different widths, but they're V's. And notice why. When x is negative, here's the x-axis, here's the y-axis. When x is negative, y is still positive. When x is positive, y is still positive. So y is never negative in this parent function.
It's because of the absolute value removes that, doesn't it?
Absolute value means that the absolute value of -7 is 7. That's why you end up with this graph. Okay?
Okay.
Now, we need to figure out what modifications we're making. How many transformations are there in this graph?
It just goes up, or it goes down then up, right? Or it's because of the V.
The 10 is a vertical shift. You have to go back to your transformations from Algebra 2.
Okay.
Remember, there's 6 transformations. You can shift it horizontally, you can shift it vertically, you can stretch it vertically, you can stretch it horizontally, and you can reflect it over the x-axis, and you can reflect it over the y-axis. So
yeah, I kind of remember that.
Transformations. There's 2 going on right there. That is 2 transformations. What are they?
Are they...
First of all, deal with the negative signs. Always first. Reflect.
Okay, so that makes it a
reflection over which axis?
The x-axis.
Okay. I'm going to draw that first. That's what a reflection over the x-axis looks like.
Okay.
Next, what's that?
So that's the y-axis.
Okay. What does it mean, though?
Up 10.
My graph. Right. Am I going to move it? Am I going to move it up 10, down 10, right 10, or left 10?
Right 10, wouldn't you?
Up 10. When you have, in other words, I really want to write this differently. I want to write it like this. Same thing. You see why it's the same thing? Remember your transformations. When you had a number at the end that was just being added to the function, it's a vertical shift. So this thing goes up 10. So there's no stretching. There's no vertical stretching going on. There's no horizontal stretching going on. So my blue line is this function. I've just written it in a manner where you can kind of see the transformations a little bit easier. In other words, you always want to do reflections first. You have to do them in that order. Otherwise, you end up with a different answer, okay, in terms of the graph. Okay. So the first thing I run into is that, the negative sign. That's a reflection over x. We did that first. Next thing I run into is a vertical shift up 10. That's different than a horizontal shift. If I were to do a horizontal shift, oh, well, that's a horrible color, it would be this. In other words, if it's inside the function, that's a horizontal shift. X minus 5. Notice that it's inside the absolute values. So if I had X minus 5, that would move 5 to the right.
Okay.
Okay. But the basic key is that all of your horizontal transformations are inside the function. All of your vertical transformations are outside the function. This negative sign was outside the function. Therefore, it's a vertical shift. Excuse me, a vertical reflection, which means a reflection over the x-axis. If I had this, that's inside the function. That is a horizontal reflection over the y-axis. Remember, everything that's horizontal is inside the function. Everything that's vertical is outside the function. If I stick a 3 right there, that's outside the function. That's a vertical stretch, which makes the function skinnier.
Okay.
Okay. If I add 4, that's a vertical shift. If I subtract 4, it's a vertical shift down. If I add 4, it's a vertical shift up. Why? Because it's outside the function. And there's only 3 things vertically you can transform, and there's 3 things horizontally.
Okay.
Okay. So our blue line is our function graphed. Now, what are the questions it asks? Where is it increasing or where is it decreasing?
It says use the graphing tool to graph the equation. So that, do you want me to make me present it?
You have to graph it. Yeah. You want to graph it where my blue line is. essentially.
Where did the V, oh, here. So it starts at 10, right, on the y-axis?
Uh-huh.
And oh, okay, I can't move it now. I don't know why it's not letting me move it.
How'd you get the slopes? The slopes aren't right. The slope should be +1 on the left. In other words, it needs to go through 10, -10 to 10. -10 on the x-axis to
So right
10.
here?
Yeah.
Up there.
Notice
Okay.
that's a slope of 1. There you go. Now that should be correct.
Sorry, I didn't mean to do it like that. It just did it for me. Like I couldn't move it again.
That's okay, but the width of that V is important because it means there's no vertical stretch factor or shrink factor. In other words, that's the same width. Notice that the slopes of those two lines are +1 and -1. That's the parent function. Unless that's been transformed, then it's always going to be that same width. All right. What's the next one say? Okay, the function is increasing on which interval?
So increasing on this side, right? So it'd be just -10.
No, because when you graph that, there's no limit. It doesn't just go to -10. It goes all the way to negative
So it'd be
infinity.
-infinity.
Yeah. In other words, it's not stopping. It doesn't put an arrow on it. That's just because you graphed it. If they'd have graphed it, there'd have been an arrow on each side.
So that's the answer then, is -infinity.
No. It's increasing on what interval? You're putting an interval in there. You need a parentheses in front. Interval notation is parentheses, -infinity, comma. Where does it stop increasing?
10.
Oh, the x. Remember, you're always defining intervals on x. 0, exactly.
Okay.
And
is that a 0 or is that an O? Did I accidentally press O?
That's it.
That's a 0. Okay. Cool.
Now, sometimes instead of a parentheses, you use a bracket. And that's if it can be that. I don't want to get off track here. Let's just keep going. The increasing and decreasing are always going to be parentheses. Always. Okay.
All right. So the function of f is so it decreases to infinity, right? So would it be 10 -infinity?
Oh, again, you're reading the y. We're defining this based on x. 0, parentheses, 0, comma, infinity.
Okay.
And
if I can find. Yeah, okay. It's just infinity? Not yet, it is just infinity.
Because we're headed towards positive infinity on the x-axis.
Okay. Determine the relative maximum.
To distinguish when you look at graphs whether you're looking horizontally or vertically. When you're looking horizontally, you can tell that that line goes all the way to infinity on the x-axis. It also goes all the way to negative infinity on the y-axis. But we're not defining our intervals based on the y. We're defining our intervals based on the x. Now, when it starts talking about maximum and minimum values, it's talking about both the y and the x. So where's the maximum? What is the maximum value of that function?
10, right?
Where does it occur? So that's 10. And it occurs when x is where?
X is 0.
Okay.
Okay, determine the relative minima. So the minimum on this function would be infinity, right? Because they're...
That's not a number.
That's not a number? Okay.
That's never an answer because it's not a number. It's a concept.
Would it be 10?
Does not exist.
Oh, it does not exist?
No, there's no relative minimum there. No matter what minimum you point out, here's the definition of relative maximum. Relative maximum is one that has a point to the left and an immediate point to the right that are less than it.
That makes sense. I got it now.
Relative minimum has a point to the left and a point to the right that are greater than it. That's all you need. In other words, you could make a tiny little dimple in your graph, and that's a relative maximum or minimum, depending on whether you made your dimple go up or go down.
Yeah.
Okay?
I see that now.
Okay. Now, graph that function.
Okay, estimate the intervals in the
Let's talk
function.
about how you graph that. First of all, what is that?
It's kind of like
Quadratic, first of all.
Yeah.
What do quadratics look like?
What do you mean by that? I don't know if I understand that.
Linear equations look like straight lines.
Yeah, that's a V, isn't it?
Equations are parabolas.
Okay.
Okay. So all we have to figure out is where this parabola goes. Now, in order to do that, probably the easiest way to do it is to factor it.
Okay.
Go ahead and factor that. What's that factor to?
Wow. So, hold on, I'm just writing it out. I'm just trying to figure it out. So would it be?
You know what? Let me do this one. I'm going to point to you again, and then just so I can explain it. X squared plus 2x minus 15. Hold on. X squared plus 2x minus 15.
So I wrote up both of the parentheses.
Hold on.
For the factor.
I want to make sure you can. X squared minus 2x minus 15. That's the function.
It's plus 2x.
Okay. First of all, factor that.
Okay, so we get the double parentheses with the x in the front. And then it'll be 5 and 3, right?
Uh-huh.
Okay.
Sign's going to be the same or the opposite?
They'd have to be opposite.
Okay. Where's the plus sign go? Where's the minus sign go?
I'd say the plus goes in the front.
Yeah.
By the 5.
And here's the key. When you're factoring something and you want to decide whether you factored it correctly, clearly that term is correct. And clearly that term is correct. It's the middle term that's always in question. Okay? Well, you get the middle term from the inside and the outside. In other words, the O and the I of FOIL.
Okay.
Add those two together, you get plus 2x. That's the correct middle term. We factored it correctly.
Okay, cool.
Okay. Now, we're looking at a quadratic that is in X-intercept mode. Where are my X-intercepts of this parabola?
Like of the factor part or of the equation?
X-intercepts means y is 0.
Okay.
Okay. So if I set those factors equal to 0, where does it cross the x-axis?
Hold on.
And just look at it. Don't put it in your calculator. In other words, you got two things multiplied together that equals 0. Okay?
You just have any
set
number x.
One of them equal to 0 and solve it. In other words, set x plus 5 equal to 0, solve that. Set x minus 3 equal to 0, solve that. What do you get?
You just get x over, don't you?
Well, one, x equals minus 5. That means that's one intercept at minus 5. And you get another one, x equals 3. There's the other intercept.
Okay.
3. Now, we know we have an upward facing parabola because the sign in front of the x squared is positive. So I have a parabola that does something like this. Where's its vertex? Can you tell from those two x-intercepts where the vertex is?
It'd be 0. No.
Got to be halfway in between.
Okay.
Those parabolas are always symmetric about the vertex, the line of vertical.
Would it be 4? No, I know it wouldn't.
Here's how you find the midway point between those two numbers. You add them together and divide by 2.
Okay.
What is that?
Oh, so we get, it'd just be 1.
Add those two numbers together and divide by 2.
Okay. So we get -5 plus 3, which makes that -2, divided by 2. So we get -2?
-1.
-1, my bad.
Divided by 2 is -1. That's the halfway point. And you can check it because that's 4 units from -5 and it's 4 units from 3.
Okay.
So we know it's the midway point. So I know my vertex is somewhere down there. We'll get to where the y-coordinate is. But this thing's going to look something like that. Now, I know the x-coordinate of my vertex, right? It's -1. What's the y-coordinate?
It would be 0, wouldn't it?
You got to plug in -1 into either of the top 2 equations you see.
Okay. So of the top 2 equations, you plug in -1 for
x. And that'll tell you what the y value is at that point. Remember that every point on this parabola has to fit this equation. So if I know the x value, all I got to do is plug that x value in, and I'll get the y value. Well, -1 squared is 1.
So it's -2 then. Yeah.
What's that?
Okay. So we get 15, 16, 17. So we get -16.
Yeah, that's the y-coordinate of the vertex. Now you know exactly how to graph it. So remember these 3 numbers.
Okay.
The 3 numbers that are important here are the x-intercepts and the vertex. Any parabola is defined by 3 points. You don't need 5 points. 3 points define a parabola just like 2 points define a straight line. Okay? So I'm going to make you the presenter again. -1 minus 16 is the vertex. So go ahead and pick the parabola. No,
And then where did it?
Pick the straight line. You need to pick that parabola right there. There you go.
This one. This is what I was trying to pick, but it wasn't doing it. I think you have to.
Ooh, what's going on?
I think it fixes itself, but like, where does it go? What was the number on the side? Was it 5?
-5 plus 3.
-5
Yeah,
plus
you're
3.
right. It does fix itself. There you go. Now you've got the x-intercepts correct.
Okay. Let's see, should I check it?
Did it give you a okay?
I haven't checked it yet. Let me check. Yeah, that's correct.
Yeah. Okay, and now determine on which intervals it's increasing. Now you can read the graph to figure out this.
Okay.
Once you have the graph, then it's really easy to figure out where it's increasing and where it's decreasing.
Okay.
Use interval notation.
So it increases on this right here.
Correct.
Or on, it doesn't increase on both sides, or does that decrease then increase?
If it's going downhill, it's decreasing. If it's going uphill, it's increasing.
Okay. So would this count right here as that when it starts increasing?
Remember, we're defining this only on the x.
Only on the x.
Rank that.
So we get -1.
Okay. To what?
3.
No. It's increasing to the right. You keep going to the right. It's still increasing.
Oh, it's infinite. It's -1 infinity.
You got it.
Oops, that's not right. Okay, x is decreasing. -infinity to 1 or -1.
The -1, correct.
Okay.
Like I said, on these whoops, what did that?
I didn't put a comma in it.
On these increasing and decreasing ones, it's always parentheses.
Okay.
Okay, just for a moment, Are we done with this question?
There's still a little bit left. It says the function has a relative maximum and minimum.
Yeah, I just want to point out. Oh, okay, hold it. Let's finish this question. Then I want to talk to you a little bit about the difference between parentheses and brackets.
Okay.
Okay. So the function has a relative maximum where?
Negative infinity, or it's just infinity, right?
Remember, infinity is never an answer. That's not a number. So it doesn't have one.
Okay, so it's not defined then?
No. The function has no relative maximum. There is no point on this function that has a point to the left and the right that are less than it. No matter if you choose as high of y value as you want, if you go to the right, y increases. If you go to the left, y decreases. So for a relative maximum or minimum to exist, it has to be, you have to be able to find points to the left and right that are either both above or both below.
I remember that now. I just need to remember that if it's infinite on that, it doesn't count.
Right. You can't give that as an answer, almost ever.
Okay.
Well, I should say almost ever. Once you get to calculus, it becomes a more frequent answer. But okay, at x where? Where does that occur on the x-axis?
1, negative 1.
Negative 1. You don't need parentheses there.
Okay.
Okay, the question is complete. Hold on a minute. I want to make myself presenter and point out something to you that you may know, you may not know. It'll be quick. Hold on.
Okay.
Give me the range.
The range? That's the domain is x, right?
Possible y values. And I'm going to give it an interval notation.
So we have 5 as a y.
Always start from, first of all, you're looking vertically. Eliminate your eyes from looking horizontally. When I'm talking about range, you're looking vertically. If I'm talking about domain, you're looking horizontally.
All right, so
we always start from negative infinity if we can. Can this function go to negative infinity on the y-axis?
No, because it goes down.
These arrows mean it goes on forever.
Yeah, that means it goes on forever.
Okay, so the range is minus infinity on the bottom.
Okay.
What's the top?
5, negative, or yeah, 5.
Can it be 5?
Yeah, that's on the y-axis.
That means that's a bracket. That's the difference between brackets and parentheses. Is if you use a bracket in your interval notation, then it can be that number. Okay, of course, yeah. There's an x value there where y is 5. It's never above 5, but it can reach 5. Okay? So I would use that as my interval notation to define the range. What's the domain on this? Just check your knowledge on domain and range.
So the domain is x.
Mm-hmm.
So
start from total as far left as you can think of.
As far left as I can think, it'd be negative infinity, right?
Okay, now as far right as you can think of.
So as far right as I can think of, would it be infinity 2?
Just infinity also, yes.
Okay.
Okay, that's the domain. Now, infinities always have parentheses, never brackets, because you can't be at infinity. Infinity means growth without bound. It doesn't mean a number. Just means it goes on forever. And this thing actually does. If I had a big enough chart, I could see that the x goes all the way to infinity. Even though this list thing looks like it's pointed down, it's got a little bit of direction in the y movement, and it's got a little bit of direction in the x. So if I continued it all the way, it keeps going to the left. If I continue this all the way, it keeps moving to the right. So the domain is, you can call that either all real numbers, but if they ask for interval notation, that's what it is.
Okay.
Okay, let me make you
Sounds good to me.
center again. Now, you don't have that so much when you're talking about increasing and decreasing functions, because what happens is it increases to a point where it's 0. It's neither increasing nor decreasing. So it's always parentheses. You rarely have brackets when you're talking about increasing and decreasing.
Okay. So it says Yardbird Landscaping has 42 meters of fencing with which to enclose a rectangular garden. If the garden is X meters long, express the garden's area as a function of the length.
All right, I need to be presenter again here. We have 42 feet of fencing, right?
Yeah.
We're talking about a rectangle that is X feet long, right?
Yeah.
Let's call the vertical measurement Y. What's the area equal to?
Area is equal to Y times X, right? Squared.
Just not squared, just X times Y. But because we know we have 42 feet of fencing, we have a second equation. That second equation is what? The perimeter of this thing has to equal 42. What's the second equation?
X times Y equals 42.
That's area. Perimeter is where you add the four sides together.
So Y or 2Y plus 2X equals 42.
Yes. Okay. Now, for me to find where the maximum area is, which is what they're asking, how do I design this garden to give me a maximum area? If I get a bigger area, I can grow more stuff. So I want to design my garden with a maximum area. In other words, if I design my garden like this, that's not a very big area.
Yeah, okay.
Depending on how you draw the rectangle, this could be 42 feet of fencing, but it's not as big an area as this one over here to the right. So the dimensions matter a lot. Okay? So here's what we do. Take your perimeter equation, solve it for y.
Okay.
It's y equal.
So with the perimeter equation we have, do we divide by each one?
Solve that equation for y. That's simple enough. Solve it for y.
Okay.
What is it y equal to?
Well, you would divide by 2, wouldn't you, on both sides? Or
Well, first of all, you got to get rid of the x. Put the x on
okay.
the other side. I'll go through it step by step with you, but do you need that? Can you solve that for y?
Well, to put the x on the other side, yeah, you'd subtract 2 from.
So 2y is equal to minus 2x plus 42. What's y equal
to? Yeah, you would divide y by each side, wouldn't you? Or not y, 2.
Both sides by 2 at this point.
Okay, so then you get y equals negative 2 over 2.
Don't give me an answer like that. Simplify it.
Okay, so we get 1x.
Negative 1.
Negative 1x, yeah, my bad.
Over 2 is negative 1.
Okay.
Plus what? What's 42 divided by 2?
21.
Okay. That's what y is. So we have two equations. That comes from the perimeter, but it allows me to define y in terms of x. So now I can go back over to my area function, substitute what I saw for y. Y is minus x plus 21. Combine those, we got minus x squared plus 21x.
Yeah, okay.
That is a parabola that opens down. In other words, that parabola is going to look like that, right? Because it's got a negative in front of the x squared.
Mm-hmm.
This point right there represents the maximum of that function, which is an area function. So that point is going to give me the x measurement to make the area the maximum.
Okay.
How do you find the vertex of that quadratic?
Do we need to graph it here? Because it doesn't say we need to. We just need to find the equation.
You don't need to. You can use pure mathematics without graphing it. And the only thing I really need is the vertex. Because like I said, this thing looks like that, right? Now, I don't know where it is. I'll draw a line there. I don't know if that's correct or not. But there is a formula for finding the x coordinate of that. And that's what we're looking for. That formula, when you have a quadratic and you're trying to find the x coordinate of the vertex, the x of the vertex is equal to minus b over 2a, the first part of the quadratic formula.
Minus b over 2a?
What's b here?
Is that the, oh, God.
If I give you, here, let me give you a formula in standard format.
Okay.
There it is. So a is the coefficient of the x squared term, b is the coefficient of the x term, and c is the number. Well, there's no number on this one, so we don't have a c, but we don't need it. What's minus b equal to?
Wouldn't it be, it would just be 2, wouldn't it?
What's b?
Because that's what.
B is the coefficient of the x term. What's b?
The coefficient of the x term? Well, x is 21, correct?
No.
So
coefficient. Coefficient means the number in front. So let's figure out what a is and what b is. B is plus 21. That's the coefficient in front of the x term. What's a?
Yeah. B. Wait, that's just a whole garden, isn't it?
Minus 1. Forget the garden.
Okay.
Now we're doing algebra. Seriously, forget the garden for a moment. When I say what is a, I want you to look at this equation we have and know that a, same as this capital A, is whatever the coefficient of the x squared is. Well, in this case, it's minus 1.
Okay.
Okay, so now we can figure out the x coordinate where this maximum is going to occur. What's minus b?
Would it just be negative 21?
What's 2a?
2, negative 1.
What's the final denominator? What's 2a?
Negative 2.
Okay. What's that equal to?
It doesn't go in equally, so.
Well, it's equal to a positive 21 over 2, is what I was getting at.
Oh, okay.
We could say that that's 10 and a half, but we don't need to. We can leave it in a fraction like that. But never leave it as this. In other words, that is always simplifiable by just dividing top and bottom by a negative 1. So that always turns into 21 over 2. Now, that means that when x is 21 over 2, that's where I'm going to find my maximum of that equation. And that equation is my area. In other words, what I'm looking at here is the area equation function. And I'm searching for where it produces a maximum y value. This is the y-axis here. This is the x-axis. Okay? And if I want to know what that maximum area is, I'll figure out the y value when x is 21 over 2. But mainly, I've found the x measurement. To maximize this garden, I want to make x 10.5.
Okay.
Now, remember my original equation, 2y plus 2x equals 42? Well,
yeah.
2x is 21, which gives me 21 for the y's in half. So they're also 21 over 2. In fact, every side is 21 over 2, and we have a square. It's not a rectangle at all, it's a square. Now, notice that this dimension of our garden fits all of our requirements. The perimeter is 42, and the area is going to be 10.5 squared. Okay, because area is x times y. We just proved that x has to be 10.5 and y has to be 10.5. So multiply those two together and you get your area. Now, I'm going to make you the presenter again. Let's see what questions they ask here. Which of the following expresses the area of the garden as a function of length, which is x? So which one of these was our area function?
Our area, we ended up it being 21, so it would be...
Well, they've reversed the order. First of all, notice, when I wrote it, I always put the highest degree of x in front.
Okay.
My answer was minus x squared plus 21x.
Okay, so would it be this one right here?
Yes. In other words, they won't always necessarily put it in the same order that you like to put it. Usually when you write a polynomial, you put the highest degree first. That's just the standard way of writing it. So
yeah, okay.
They mixed it up there just to test you, I guess. What's the definition of a rhombus?
It's got 4 points, right?
It's a quadrilateral. It's a four-sided figure, but there's a very specific definition of a rhombus. All four sides are equal. That's the definition. If you can draw a four-sided figure where all four sides are equal, you have yourself a rhombus. Now, it turns out that this is really one of the few ways you can draw it. A square is a rhombus. A square has four equal sides. But the difference between a square and a rhombus is a square also has four 90-degree angles, whereas a rhombus does not have to have four 90-degree angles. Notice that I could compress this horizontally without changing the lengths of any side. In other words, right now it's in the shape of a diamond, but it still looks like a square if you tilt your head. Okay? But let's say I compress it horizontally, well, then you're not going to have four 90-degree angles, but you're still going to have four equal sides.
Yeah.
Okay? Or if I compressed it vertically, I'm still going to have a rhombus, but I'm not going to have a square. So squares are more specific than rhombuses are. Every square is a rhombus, but every rhombus is not a square. Not trying to confuse you, but terminology is important in geometry like this.
Okay.
In other words, a rhombus merely means four equal sides. It does not mean that each angle has to be something.
All right, so the rhombus is inscribed in a rectangle. W means the side with the. Okay, so if the perimeter is 44, that's all the areas around the edges. You can just divide it by 4, and each side is 11, correct?
Correct.
Okay. Each vertex of the rhombus is a midpoint of the side of the rectangle. Express the area of the rhombus as a function of the rectangle's width.
I need to be the presenter on this.
Okay.
And the only question is, it's noon. You want to begin the next session with this problem, or you want to finish this problem? And
yeah, we can do the next session because I gotta go back in like 30 minutes. So
that's fine.
So yeah, we'll do it next session
I will
after
talk to you
school.
in 3 hours. Let me make sure. I wonder if I have to be the presenter to close it out. I'm going to make myself the presenter just because I've never tried closing out GoToMeeting with the other person being the presenter.
Okay.
Okay, so I stopped.